So I'm not going with the network virtualization now because it's very important. Very important means I can able to explain very good way, and of course, okay. But storage virtualization, because we know so many things, I can explain it very easy way. Okay, know a lot of things about storage, and also we can able to explain that one. Okay, so first of all I want to explain with a very simple way, so because I want to repeat storage, so this is very easy, guys. I will tell storage virtualization, then I will finish up today. Okay, good to hear or bad to hear? Okay, whatever it is. So normally, so concept of virtualization is, if you store data and you look at the data, and very straight away it is in your local storage. If data is in your local machine or a local drive, so that is data storage, right? The concept of virtualization is, it not required to be in a local, so it can be anywhere, but you should look at this data, it should be like it's look like a stored in local only, but actually not in a local. So that is a concept of virtualization kind of stuff, right? It is not required always the same thing. So here it is a point. Well, what are the examples we can able to tell for a storage virtualization? Based on the virtualization, we can able to understand. First one, I want to tell, you have a hard disk, right? It's a single straight hard disk, right? It's a single straight hard disk. Hard disk is single straight. Okay. One physical hard disk. You purchase one physical hard disk. For example, it is a 500 GB or 1 terabyte, 2 terabyte. Anything you can take it, no problem. Okay. And I am dividing like this. What we can say like this, if you divide a hard disk into small parts, anyone, last part, guys, and it is repetition. If you divide a hard, we call it as a partition. We call it as a partition. Divide a hard disk into, okay, divide a hard disk 500 GB hard disk into different sizes, 550 GB, 100 GB, maybe 20 GB, or maybe another 50 GB, like that. So small partitions, okay. But physically you are not dividing it, you are dividing it in a logical way. Okay, we are dividing the physical hard disk in the logical way. But virtually we say, virtually it is a, physically it is a single hard disk, virtually it is a multiple hard disk. Virtually it is multiple hard disk. The virtualization concept is very old. Virtually it is multiple hard disk, but physically single hard disk. This is okay. But don't tell this example in an interview or someone is asking. But if someone is explaining this one, no need to hesitate, like you already know, don't need to say I am already know. So you say, if he's a senior, very good. If he's a junior, you can say I know already this one, I think you don't know this one. That's why I told differently. A lot of things are there. Next, we can combine more than one physical hard disk, right? But physically you are not combining. There are physical hard disk only, like a disk 1, disk 2, and disk 3, like this. We can combine multiple hard disks and we can create a single volumes. We can create a single volumes. Okay, so total disk we can get like a stripped volume, mirror volume, RAID 5 volume. We can able to create it, right? RAID 6 volume we are creating. So one disk, two disk, or three disk, we are combining physical hard disk logically we are combining and we are creating a huge volume sizes. Okay, so also we can say virtually we are combining because you are not combining physically. We didn't open the uh, your hard disk and put all platters together, make it as a single volume. You are not doing it. There are separate hard disk only, but what you are doing logically, you are combining. Also we can say virtually we are combining. Virtually it is 2 terabyte of disk, but physically it is 1 terabyte of disk. Like that, this is the volume concept. One more concept is I like this to concept to say exact word we use, that is called virtual hard disk. Guys, anybody remember virtual hard disk? Hmm? Anybody knows LVM? Anybody knows LVM? Linux administration. Okay, if it is no problem. There is a terminology, just I am typing. Okay, so this is the terminology we use in the LVM concept, logical volume manager concept. Look at this picture. So I will tell. For example, I'm taking two or more disks. So minimum two or more disks are empty leftover spaces from the other disk also we can combine. So here is a, for example, each individual disk is a physical volumes. Each individual disk we call it as a physical volume, like a physical volume 1, physical volume 2, physical volume 3, like that. So for example, I'm taking 500 GB, like that. Maybe this is 1 terabyte. Maybe this is another 500 GB. See, regular or irregular, no problem. Okay. So these are all physical volumes, PVs. Separate hard disk. This is disk 1, disk 2, disk 3. Physical hard disk. I combined these all disks and I created a volume group. I created a volume group. Physical volume means individual volumes. I created a volume group. The volume group means combination of multiple physical volumes. Combination of multiple physical volumes. So how much now? So 500, 500, 1 terabyte. The size, total size of volume group is 2 terabytes. Total size of volume group is 2 terabytes. Now, there is a client, okay, required some space from this 2 terabytes. Space from 2 terabytes. How much is 1.5 or maybe 1.8? Okay, so no disk is satisfying that one. So we can combine. So 2 terabytes, from 2 terabytes you can take it. That's for an example. I'm given another example I want to give. For example, client required a 20 GB hard disk. So instead of taking from volume, physical volume, so 20 GB from 200 GB. Sorry, 20 GB I'm taking. No, not 20 GB. Take 200 GB best. So client required 200 GB volume from my volume group. For my volume group. So what I'm going to do is I am taking 200 GB from my Okay, so 200 GB, so less is good. Okay, 200 GB I'm taking from my this size, and this is called logical volumes. So what is a physical volume? Physical hard disk. Volume group, combination of physical volumes and create a huge volume. Okay, and within this huge volume means in a volume group, you can create a logical volumes as per your requirement. As per your requirements, you can create a logical volumes. This is the LVM concept, logical view volume manager concept. Guys, understand? No replies. Okay. So already I told in a volumes. So I am telling right, guys. In a RAID we have a redundancy concept. Like one disk is failure, another disk is provided data. Okay, so redundant array of independent disk. Okay, so if one disk is failure, other disk will give you data. So that is a mainly base of RAID concept. Okay, but LVM concept won't give you redundancy. Means if any disk is failure, the data stored in the disk is gone. We can't access anyway. Okay, no redundancies. And in a RAID, compulsory RAID levels, you have to take every volume size from the physical volume must be equivalent, like 1 terabyte, 1 terabyte, 1 terabyte. But in LVM, any piece of empty space you can add it to our LVM. So you can irregular shapes also we can add it to LVM. Okay, and here that's pretty straight management, like RAID is a either this stripped volume or mirror or RAID 5 only we are creating like that, pretty straight. But this is layer by layer. First physical volume, combination of physical volume is a volume group. So in the volume group you are creating logical volumes, like a small partition you are taking from it. So like this is concept. This is directly disk access. In a RAID we have a RAID 0. So what is a RAID 0? It is a strip, stripped volume. Okay. So combination of anyone. If you study, please tell me. No study. Combination of two or more disks and create a single large volume. Okay. So that is a RAID 0. Okay. So no disk failure. Meaning is if any disk failure, data total data loss. Total data loss means no one can access data. Okay, no one is access data. No parity. Anyway, okay. So next one is RAID one. So RAID one we call it as a mirror. We call it as a mirror volume. So combination of how many disks? No one is speaking. Nothing again. No studying or otherwise not interested in class. Combination of two disks. Only two disks. If it is called a single disk failure, single disk failure without parity means if any one disk failure, okay, user still can access data. Okay, so here no access, here still we can able to access the data. Okay, so how much volume you will get is total volume. Total volume you will get it. Okay, wait. RAID 5 is nothing but RAID 5 volume only. Views 2 are no 3 are more disk. Again, it is also single disk failure with parity. Single disk failure with parity. Okay, so if one of the disk failure, still user can able to access data. Same thing. This is also same thing. Okay, so this is volumes, and I said partitions. In the partitions also, I will want to tell. So like MB or type disk. Okay, it will give four partitions, four primary. Okay, or three primary plus one extended. Okay, and max support 2 terabytes. Next GPT partitions. Okay, 128 primary. Okay, max more than 2 TB, or max is 18 TB. All are every concept comes there only. There's one more point I want to tell. That's because no one is speaking. But what I do, I can't do anything. It's 6:30. Okay. Another concept is virtual hard disk. Okay, virtual hard disk concept. VHD, virtual hard disk from Microsoft. These two are from Microsoft. .vhd and VHDX. Microsoft. Okay, VHD concept. So it is a file stores in your physical machine, and it stores in your. So what is the VHD format? Is formats are VHD and support up to 2 terabytes. Not VHDX, uh, more than 2 terabytes and up to 64 terabytes. That is VHDX format. Okay. So from VMware virtual hard disks are VMDK files. VMDK. Okay. So other different formats are there. For example, Linux virtualization concept is there, no KVM, QEMU. So that is dot QCOW2. So this is the formats of different formats of virtual hard disk. Okay, so this is also virtualization. It's a pure form of virtualization, you can say. For example, I created a virtual machine. Oh, sorry, virtual hard disk here. If you see, last time I explained virtual hard disk. You can store the data as your physical hard disk, but it is a file in the form. It's a formation is a file, and you can store the data, and you can connect the disk as a normal hard disk, store your data, and you can able to disconnect it also. That is a virtual hard disk. And if you, these are the VMware virtual machines, you can open any VMware virtual machine. You can see .vmdk. This is the VMware virtual hard disk. Okay, so what are the left? Okay, so centralized. So types of storages, storage types, dash, directly attached storage. Okay, another one is NAS and SAN, network attached storage, storage area network. This is local storage is a dash, central is a NAS or a SAN. Okay, so we have a storage pools and all. We combined all the storage pools, create a LANs in it and assign it. Okay, these are all that kind of stuff only. Yeah, lock level. No one is responding anything. I am getting a lot of pain here. Okay, this is it about your storage kind of stuff. So tomorrow, once again, if possible, tomorrow, day after tomorrow, we'll discuss these things again. Okay, this is about your storage virtualization. Mainly, at least try to get this thing. Understand? Already we done a practical. I showed in a practical, so try to do it. Okay. Tomorrow I will show you Hyper-V in first. Then we'll start with the Python installation and all. Okay, guys. Okay. Now your people are speaking. Okay, so I'm going to disconnect first.